Hi, my name is Felipe Lima from the Federal Institute of São Paulo, Campus Matão, and today I will provide a tutorial how to build a molecule with solvation shell, right? With yeah, that's it. So in order to run this tutorial, I will follow these 6 steps here, okay? The first one, I'm going to grab an input example from Packmol website. Second, I will draw the molecule system protein and save it into the PDB format. This is really, really important. Third, we will download the solvent ion structures that I want to use into the PDB format as well. And fourth, I will modify the input file that I got from step 1. Then I will run the Packmol, and the last, I will check the results into the visualization software. Okay, so let's see what we have here. But what is Packmol? Packmol is a software developed by the Institute of Chemistry and the Institute of Mathematics from the University of Campinas, and also the Institute of Mathematics and Statistics from the University of São Paulo, right? What Packmol does is it creates an initial point for molecular dynamics simulation by packing molecules defined by region of space. And the most important thing is this one. The packing guarantees that the short-range repulsive interactions do not disrupt the simulations. This is really, really important, right? So let's go to the first step, grab an input example. These are very good starting points. Look, there's several different input examples here. I will start from the last one, okay, which is a protein and a spherical solvation channel around it. In order to do that, I will grab this solve protein comment.imp, right? After I download that, let's move to the step 2, which is draw the molecule system and protein and save it into the PDB format. In order to achieve that, I will going to use the Avogadro software. Okay, the Avogadro software is here, and I will draw, for example, a porphyrin molecule, right? So I'll go here, build, insert fragment, and grab a porphyrin, right? So here you go, easy peasy squeezy, right? Hey, the porphyrin, beautiful porphyrin, but oh, Felipe, this is not exactly the same that I have. I need some radical there, so no problem. Just select an atom, go and insert, and go build, insert fragments, and add the fragments of your preference. I don't know, maybe aromatics. You know, a purine. Hey, done. Right? But it seems strange, right? It should be like that. This is too close. In order to fix those too close problems, you can go here into the auto optimization tool and press start. It will just run a molecular mechanics, a very simple molecular mechanics in order to adjust the system, right? It's not a very big issue. As you can see, it gets some angles here, and we are good to go. Remember, this is not a complete molecular dynamics run. This is just a very, very rough start to run the simulations, right? So afterwards, I want to save it into the PDB format, right? So I will select the folder that I'm using and save it into the PDB format. So porphyrin modified.pdb, okay? So I will press save and save it. Then I can close it. The third step would be to download the solvent and ion structure that I want to use, also in PDB format. Luckily, the example that I've chose here already has one water molecule in PDB format, so I just download it and I will use it, okay? Then the fourth step will be modify the input file from step 1. for this, I will be using a terminal, but you can use the Notepad++ to do that as well. I will open the Warframe, the input that I've downloaded. So it is here. Everything that starts with hashtags are the comments. Okay. So this is a very important point because it will be the tolerance, which will be the minimum distance between the solvation atoms, and also the file type, which will be the PDB file. Okay. The output result, right? Like in this case, I will ask as a PDB porphyrin modified slash solvated.pdb. Then here I'll use my structure, which will be the porphyrin modified. I want to have just one porphyrin, so the number here will be 1. It will be fixed at the 000 point, the 000 XYZ direction, also with restraint into the movement. It won't move it at all. And also, I will ask the software, the Packmol software, to put this molecule into the 000 will be in the center of mass of the molecule that I've chosen. After that, there is the second part would be the solvation, right? So in order to do that, I choose the water PDB structure. I choose 200 molecules around a sphere of 5 angstroms radii. Okay. If I want to use some ions, I can add the ions here as well. For example, I can copy and paste here and add some ions. I don't know, maybe chlorine.pdb, for example, and I want to use fluorochlorine around the very same structure. As well, if I have chlorine, I want to have sodium, right? So here we go. So minus 4 charges, plus 4 charges, we're good to go, right? Nice, but it won't be in my case. Just showing you as an example how to add some ions if you need to balance the charges of your system, right? After I finish that, I can save it and I will run. So I will count Packmol, minor, and the file.input. Okay, the input was a success. The violation of the constant is 10 to times minus is in order of 10 up to minus 3, which is fairly okay. And well, it is less than 1 second. Amazing job. Let's see what we got. I will open the output file here into my software of preference, which is the Discover Studio Visualizer. And as you can see here, hiding the water atoms, I have the molecule, and then with the water molecules, I have the shell, which remembers clearly sphere format, right? So this is it. Okay. Let me know in the comments if you like this video and if you want to have more tutorials like this one. Okay? Thank you.